Hi dear MECH 533 students. This record is about the design tools of Inventor for bolt nut type joints or for cap screw threaded hole type joints. Okay. Start. Well, I'm going to inform you on the design tool of Inventor on bolt nut type joints using this example. There is a joint here, you see it is for connecting two L-shaped prisms. What we have here, we have a bolt. This is a bolt, well, say isolated if you want from the rest. Okay, well, together with what? Nut. This is the nut and that one is the bolt, and two washers at both of the sides. Yes, actually watching the video records about how the model of an assembly created, what is pack and go process, how the work is defined as a project, you learned all the necessary things about model creation. But this video record, I want to provide the complementary things. Say it is just on computer aided design for bolt nut or cap screw threaded hole type joints. Well, you know, to be able to have the model of such a joint, well, this design tool is recommended. Well, in Inventor environment, we have some conveniences. These are for having bolt type joints, pin joints, well, magically in few minutes the model of a bolt joint. But say not only bolt, clicked on this one, for instance, yes, can find two types, whether the joint is a bolt nut joint or cap screw threaded hole joint. So, well, it is a multifunctional facility. This one similarly, well, multifunctional facility. It is for creating the model of clevis pin joint, secure pin joint, cross pin joint, joint pin, radial pin connections. These are not the facilities not to have the model, create the model of the joints, but also to perform engineering calculations, the facilities. For instance, insert frame is a tool to create the model of a structure. It may be a frame, it may be a truss, okay, two-dimensional, three-dimensional, can create the model and also, well, at the stage, design stage, perform the engineering calculations using frame analysis facility. This and that are associative facilities. Shaft creation tool, gear creation tool, okay, pulley belt mechanism or sprocket chain mechanism, key connection wizard, and some others. Yes, these are design tools. Those can be found in the structure of Inventor. Well, I have created this joint, okay, using this facility. If this facility is used, either at the creation stage, well, clicked on this and start the creation stage. If you select design option, then you can, well, define where is the joint. It starts from which plane, ends at which surface, okay, and then, well, which kind of fastener you're going to use, the bolt in accordance with the rules of ISO or in accordance with the rules of American Association, which kind of bolt, which kind of washer, etc. Well, in the design dialog can fix all the things. Well, if you watch the video record, it is about say bolt nut type joint creation stage. You can make a review one more time, find the video record, and then see what it is, how it is created. But well, at the creation stage, well, clicked on calculation tab and then deal with the design stage, calculation, engineering calculation stage. Well, this video record, well, my purpose is that say how you can use this calculation facility. Since I have already created the joint, just here I'm going to rebring the dialog box. It is to have in the environment at the model creation and design stage. How? Bring the cursor to the browser. Since this joint has already been created, well, that is the corresponding facility. Say the icon, it corresponds to this facility. This facility has been used, this joint has been created, and that's the corresponding icon at the browser. Well, if you're going to delete the joint, or if you're going to modify the joint, or at least if your purpose is to have a look at, then the first thing to do is the same. Move the cursor to the browser, bring the cursor onto the icon. It corresponds to the joint. Right click the mouse, and this menu will drop. From this drop down menu, if you select delete design accelerator component, yes, these are all called design accelerators, or say design facilities, design accelerators, or design wizards. So well, Inventor use design accelerator. Why accelerator? It means in the analogy, if you use such a facility, then you can finish the work at a shorter time. Okay, that is the implication. If your purpose is to delete the joint, then click on this option. But if your purpose is to edit or to have a look at, well, at the creation stage and design stage, which parameters have been used, what are the selected materials for the components, etc. Bring the cursor onto edit using design accelerator option. Edit using design accelerator, and then make a click. After the click, yes, the same dialog box appears at this stage. Well, I have created this joint, selecting this type of bolt. It has been designed and manufactured in accordance with the written things in the document of ISO. It is code 4018. Okay, and well, the diameter of the bolt is 10, and capital letter M, it precedes, implies that the thread form is in accordance with ISO, isometric thread form, and 30 here is the length of the stem of the bolt. If you watch the video records, these are about threaded features. You can clearly understand, clearly see the meaning of such a standard designation node. And well, I defined that at both of the sides gonna use washers, and these are the standard holes. Using this facility, well, can have the model of both nut washers, and also can create the holes, necessary holes within the components, okay, in alignment with each other, and also in the corresponding standard size. Okay, well, while having the model of the joint, or just after having, then well, clicked on calculation tab, and then well, you selected, for instance, 10 millimeters as the bolt diameter. And you know that as the designer of the object, at the joint, this joint is for applying in the axial direction such a force, F sub A, axial directed force. It is for gripping purpose. Gripping purpose. Well, grip the components. There are two components. Yes, this and that. Well, try to take an annotator. Take a pencil, pen. Well, I think here writing this registered threaded name of the software, I can find that annotator. Sorry, well, here I should follow this way. I think I pivot. And then run the software to have an annotation facility. Yes. And then take a pencil. Yes. Well, screw the nut against the bolt, and then make the distance L smaller, and of course, in the end there will be such a gripping force, okay, applied by the nut onto the components, and of course at the opposite side such a gripping force exerted by the head of the bolt. These forces are needed to grip, to hold, to connect these two components. So action-reaction principle here, FA, axial force, is the reaction of this action. Okay, it is exerted by the workpiece, by the object onto the head of the bolt in the opposite direction. So erase those lines and then see the existing things. Well, FA is such a force. We know to be able to hold the components, what should be the gripping force. In the example, say that I know as the designer, or as the one person, I know the demands of the customer. Gripping force, maximum axial force to have here for gripping the components is 800 newtons. Okay, well here what is that? This is a force. Say that this component in our model, for instance, this L-shaped prism gonna be under the action of such a tension force. Okay, and that one, the other one, will be under the action of such a force in the opposite direction. Say that we have such a load in addition to the axially directed forces, their effects just to shear the body of the bolt at this cross section, like the effect of a scissors. We have these forces. Okay. Take an eraser and clean. And then here, in the axial direction, the magnitude of the force to have for gripping the components is 800, let's say. Well, tangential directed forces, not 0, but say that these are 500 newtons. Okay. Tightness factor 1.5. What else? Safety factor. Say that, I'm not so sure the manufacturer of the bolt, okay, just obeying to all the written things in the standards and satisfied, and so bolt is a reliable bolt. During the manufacturing there may be some mistakes at this stage, so the strength of the bolt may not be say in the order as it is fixed in the standard. So it's factor of safety in such a case. If you're not so sure on the quality of the production, then for being safety side we use safety factor. Well, here factor of safety for this bolt nut joint, let's say 3 times safe. I want to have the joint, okay, as 3 times safe than the ones mentioned in the declaration form of this product. Okay, the components made of what? Made of which kind of material? Okay, clicked on this little box. If the material of the L-shaped prisms, the components, these are the components to grip, will not be say assigned already, then yes, you can do it clicking into this little box. And from the list of the materials, it is a long list, you see, select the material of the component. Say that material in accordance with the is made of the material, it is in accordance with the Society of American Automotive Engineers, and it is code is this one, and then say OK. Well, after selecting the material, then the modulus of elasticity for the material of the component is automatically written into this box. It is in this order. Okay. Well, Inventor knows the length of the bolt to use for this joint, and here automatically written value is the functional width into this box. It is automatically written. Well, Inventor knows the thread diameter. Well, here I selected diameter of the bolt as 10, so it is written over here. Pitch value of the thread is 1.5. These are about the threaded part mainly. And how many bolts at the place? Okay, you have one bolt type joint only, but there might be more in series in parallel bolt nut joints. Then if the case, then change this number. This part is, this pane is about bolt material. Well, the bolt is made of this kind of steel. How you can change it? Clicked on this triple dot, and then from the list change the material, replace the existing one with a different one if necessary, if it is the case. After selecting the material of the bolt, and normally it is recommended to use the nut as made of the same material, then can find the mechanical properties. You see here within these boxes, this number is the yield strength, and that is the modulus of elasticity. Okay, and for the thread, allowable thread pressure. Okay, these are all fixed, and then the rest. Check whether for such a loading our connection is safe. Can use such a bolt. Clicked on calculate button, and then yes, you see here we have some red colored values. Before focusing the attention to the red colored values, then see along the results, in the results pane along this list, what we have, okay, as the calculated values. This one, press stress factor. Bolt is an elastic member actually. While we're screwing the nut against the bolt or vice versa, well, it is like a spring. It is elongated, it is stretched, okay? During the screwing stage, well, need to, while we're applying the necessary tightening torque, okay, well, we have an axially directed force. It loads the bolt and also in the opposite direction grips the components. And here, during the screwing stage, the maximum axial force driven value is in this order, 3000 newtons. Well, preset force, well, after removing the driving torque, then we're going to have a force, okay, to grip. Well, here, this is the preset force near to 3000 newton, and this is what M sub U is the screwing torque, necessary tightening moment. To be able to screw tight the bolt against the nut or vice versa, such a torque, 9 newtons meter torque is needed. Okay, and sigma sub T is the tensile stress. Well, the tensile stress here for the bolt material, 56 megapascal. Well, you see, yield strength for the bolt material, 346 megapascal. Tensile strength. Torsional stress, while we're rotating the bolt against the effect of friction forces, okay, well, it is going to be under the torsional stress. Okay, this is the torsional stress, 85.6 megapascal. And well, here maximum stress from maximum force, 58 megapascal. And this is the thread pressure. Well, the flanks of the thread, teeth of the thread will be under the effect of surface pressure, and that is the value. What is this? Why it is red? The reduced stress, it is in red color. Well, it is the maximum stress value for this bolt. It is in red. Why? Because factor of safety here for this joint is 2.17. But here, as the designer, I said that factor of safety, I want to be 3 times at the safety side. Although I said that safety factor is 3, when I calculated, finished the calculation stage, under such conditions for such a loading, and the diameter of the bolt, of course, well, you see factor of safety is less than 3. That is why here we have a notice. Inventor saying that the safety requirement is not met. Calculated safety factor is smaller than the required safety factor. So calculation indicates there will be design failure. What can we do? Well, replace the bolt with the one. It has been manufactured by another company, and it is more reliable company to it is manufacturing quality insurance system. So, well, for such a bolt, factor of safety, for instance, not 3, but it is enough to use 2 as the factor of safety. 2 times be at the safety side. Okay, then calculate it again. Now you see there is no red colored one. Yes. change the force. Say that for gripping this components we need to have not such a force but greater 1.8 kilonewton gripping force is needed. Okay, now recalculate in this case because I changed the parameter. Yes, now you see the stress value is not the same. Factor of safety in such a case less than 2. Again, I have red colored values. So Inventor noticing me that, well, if the force exerted in the axial direction or to have such a force in the axial direction, then factor of safety cannot be 2, 1.5. So this joint won't be safe joint. Avoid using such a set. Okay. Yes, this design tool of Inventor, you see, just enables us to see whether our design is safe, secure design. If not, then well, either change the diameter of the bolt or change the material, or what the manufacturer find a more reliable product. It has been manufactured by a more reliable company. So factor of safety may be not 2 but 1.5 for instance. But the suitable solution in case of being in such a failure, if it is used although there is such a notice, then well, increase the size of the components if it is allowed by the customer, and then use a greater size bolt. Okay, for instance, at present, this is not a safe connection, but here I'm going to change the diameter of the bolt, not 10 millimeters bolt, but say 14 millimeters bolt. But of course, to use such a greater size bolt, the material, okay, over there, it enables, say, the component should be sufficiently large. May need to increase the size of the component for having such a joint over there. Okay. After changing the diameter of the hole, you see Inventor, this wizard of Inventor automatically replaces the size of bolt, washer, size of the standard holes, and what else? The nut. It is automatic. And then, well, recalculate the equations for checking whether stress value and factor of safety going to be less than the limits. And yes, great. You see there is no red colored line, red colored number. So if I change the diameter of the bolt from 10 to 14, then it is going to be okay. Factor of safety 3. Okay. Although I said that 2 factor of safety, 2 times being safety side is sufficient. Okay. Now, of course, to be able to save the material, then after seeing that 14 millimeters is just the bolt size, it enables us to be 3 times at the safety side, then of course can decrease the diameter, not 10, not 14, but well, try to use the standard bolt, 12 millimeters. Okay, and then recalculate. Now factor of safety 2.2, it is greater than the minimum factor of safety fixed by the designer, so we can use this joint. In the axial direction, preset force, well, 4,355 newtons. Okay, working force 4,575 newtons. Okay. Tensile stress is equal to that much. Shear stress at this cross section, and reduced stress is equal to that much. Combined effect. Okay. Yes. Dear students, I think the subject is clear enough. Be aware for bolt nut or capsicrew threaded hole type joints, we have such a calculation tool. Okay. Yes. If it were the joint, not bolt nut, but well, capsicrew threaded hole type joint, then select this one and then see in the calculation dialog box, well, have similar things and then deal with it. Of course, since the existing one is bolt nut, not a capsicrew, then well, here in the schematic figure, Inventor knows that it is not a capsicrew type connection but bolt nut type connection. What I have the schematic view of such an assembly, not bolt. But if it were capsicrew assembly, then I would find a different schematic figure over there. Here there is a list, well, depending on the design case. Well, if you select bolt diameter design, then yes, well, such a case, the bolt diameter will be unknown. Okay, and calculate what the bolt size calculate. Well, here you see the thread diameter, bolt diameter, the diameter of the threaded portion. If it is the case, well, we know the forces, but the diameter of the bolt has not been fixed. Or in other design case, the bolt size has been selected, okay, but we don't know how many bolts need to use in series. Then if it is the case, then well, select this option, and then when you say calculate, here the main result, valuable result, will be on the number of bolts, how many bolts are to be used. Okay, Inventor will ask this question. Or bolt material design, say that you know the diameter of the bolt, but you're in difficulty in selecting the material. Then say the unknown is the material, all the other things are given, known or fixed. Run the software, calculate, and well, see which kind of material, of course, to its mechanical properties are recommended by the software. Or check calculation option, yes, and then for the already selected bolt, then well, can check the calculation. Okay. Yes, a powerful calculation facility, design facility. Okay, it is for bolt nut type joints or capsicrew threaded hole type joints. Okay, they are all. I think you understood well how it is used, what is that, and how it is used. Saying that, that's all for this video record. Stay healthy. I wish you success. Bye bye.